Let's take a look at an example for Chapter 10. So a study uses 2 random samples of 35 people. Each found that the average amount of time those in the age group of 26 to 35 years old spent per week on leisure activities was 39.6 hours, and those in the age group of 46 to 55 years old spent 35.4 hours. Assume that the population standard deviation for those in the first age group found by previous studies is 6.3 hours, and the population standard deviation of those in the second group found by previous studies was 5.8 hours. At alpha equals 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? So the first thing that we'd like to do is set up our hypothesis testing. So some things that we should maybe make note of is I'm going to introduce some subscripts here. So I'm going to say mu sub A. This is going to correspond to the mean of the 26 to 35-year-olds. And then I'm going to use mu sub B is going to be the mean of the 46 to 55-year-olds. Now, I do that because since we have 2 groups that we're working with here, we have to be able to differentiate between what are the variables that I'm using within each group. So if I have mu sub A, basically the subscript A corresponds to anytime I'm talking about the 26 to 35-year-olds. So when I look at the hypotheses that I need, I always have my null hypothesis. And in this case, we have to figure out, okay, what are we trying to study here? Are we looking at means? Are we looking at proportions? Are we looking at 1 sample, 2 samples, all of those things? So notice what we have here is that we have this group here of 26 to 35-year-olds. Then we have a group of 46 to 55-year-olds. And what we're trying to figure out is there a significant difference in the average time each group spends? So we are looking at averages or means. So we have this idea of means and averages. And we have these 2 distinct groups. So there are these 2 independent groups. There's no one in between. There's no one who's in both of these. So this tells us that we're going to have these 2 samples with means. So we should be using means and 2 samples in our hypotheses. So we have our mu sub A is going to be equal to mu sub B. So we say that there is no difference between these. Now our alternative hypothesis, we're asking, is there a significant difference in this? We don't know which one is more, which one's less. We're just seeing, are they different? So our alternative hypothesis is mu sub A does not equal mu sub B. So now when we try to figure out which test we have a 2-sample test. We're looking at means, and we're trying to figure out, do we have a known or unknown population standard deviation? Well, we know the population standard deviations here for both of them. So since we have both of them are known, we do have known population standard deviations. And then we can also make a note here that this is a 2-tailed test. But these 3 right here, this tells us what type of test we want to use. So if we turn on our calculator, we can see some of the names of them if we'd like. So if we press stat, go over to tests, and we scroll down a little bit, we see that we have these 2-sample z-tests and 2-sample t-tests. So this will be a 2-sample z-test. Remember, z is going to happen when we have a known population standard deviation. So if we go over here to our 2-sample z-test on the calculator, we press enter. We have the choice again of entering data or statistics. We have already calculated statistics. And so when we have our data that we're entering, we have to enter in our sigma sub 1 and sigma sub 2s. So in this case, we really have this mu sub A would correspond to subscript of 1. So we put in our first population standard deviation. We have 6.3. We go down to our next population standard deviation, which was 5.8. We have our first sample mean, we said was 39 0.6, our total number of people. So we had 2 random samples of 35 people each. So both of them are going to have 35 people. So the mean of the second group is 35.4. The next is 35. Now we have our alternative hypothesis. We see they're not equal, so we choose that one. We scroll down, and now we choose calculate. And so we can scroll down and we can see all of our numbers. We can verify those. But the important things that we have now been able to gather is we have our test statistic. This is going to be z is equal to 2.902. And then our p-value that we see on the calculator is 0.0037. So now that we have these, we can now finish off our hypothesis testing by comparing the p-value to alpha. So we see since the p-value is equal to 0.0037, and this is definitely less than 0.05, which is alpha, we reject the null hypothesis. We reject the null hypothesis. So as a reminder, our test statistic, this is pretty far away. So if we think about our normal distribution that's taking place here, we're over here at 2.902. To be as extreme or more extreme in this case, we're going to be either off in this direction or we'd be over here at negative 2.02 and we'd be off in this direction. Remember, we have this two-tailed test that tells us to be as extreme or more extreme. We'd be way off onto these sides. And so this is going to be a very, very small area, obviously given by the small p-value. So we reject the null hypothesis. We have sufficient evidence to believe there is a significant difference. There's a significant difference in the average time of leisure activities per week. And there we go. We knew that there was a difference. Statistically, now we see that is a significant difference, right? We saw obviously the means were different, but we see that it is more than just random chance. We are convinced that there is something special going on, something different between these two groups.